Hi, guys. So we'll just start without the embarrassing stuff. Continuous workflow implementation is never a one-size-fits-all solution. Every product in every company does that differently, either due to the nature of the product or the technology and other different considerations. This talk might not be relevant as a whole, but we hope some parts may be relevant to some of you. So this is Shalom. Aside from speaking Mandarin, he also is chief Dev Happiness Officer of the mobile developers at Wix, and I'm Rotem. I work mostly on detox and on our CI flow. As part of our mobile infrastructure team at Wix, our team helps defining and managing mobile stack across the company. We mainly do infra work. And we try to improve the dev experience by creating tools for our developers, automating all the things, and arguing, like a lot of arguing. The unique thing about the work that we do is that most of it is open source. The core business of Wix is helping small businesses with their online presence, either if it's a simple site, blog, or online store, showcasing professional photography, music, videos, and more. Every product group in Wix is an independent entity, and it develops its product with minimal dependencies while sharing infrastructure with other product groups, whether if it's server, mobile, or web. The Wix app is a complementary product. It contains many interoperable products, either in a mobile form, complementary to the web product, or a totally new experience. The product requirement drove the current architecture of our app, the way we build and the way we develop, integrate and release, and the release process. And this is what we want to share with you today. So the Wix app is our official iOS and Android app. It's written from scratch in React Native. It has been being developed in the past 2 years. In terms of engineering efforts, there are currently 40 developers working on the project or supporting it with infra tools like we do. The majority of the code is written in JavaScript, and we try to keep our infrastructure native and business logic in JavaScript. And the app is cross-company effort. It currently incorporates code from 7 different product groups. The fact that each group is independent drove for a modular architecture. The app consists of multiple product modules. So a module is an independent product unit. It can communicate with other modules. It consists solely of JavaScript code. It has special API, declaration file, and all modules runs on top of the engine. The engine is our way of conforming and allowing all module owners a way to run their tests separately, the test and development separately of everything else. But at the same time, they use exactly the same native dependencies and JavaScript APIs as the full application. In a sense, it gives the freedom to treat modules as pluggable extensions to the application, enabling creation of independent apps if we want to. The engine is packed as an NPM package, holding all native and JavaScript sources, a command line tool for common tasks, and also a pre-built version of our app or APK. This allows module owners to skip the native compilation process, which is unnecessary for them, since all of their business logic is JavaScript anyway. So the module API is the app's way of registering and communicating between the modules. It lets each module define its API, export components, methods, and register for app-wide events. So every module declares its own API. It has few lifecycle hooks like init and on upstate change. And it exposes components for making components from that module accessible to other modules. Things like full screen views or just views, shared screens, could be error screens or things in that, like checkout screens and etc. Methods is like an RPC-like interface that allows remote calls to other modules functions. and a few more register broadcasts for a pub sub. It's a pub sub interface for system-wide events. Okay, so each module is free to use every native extension available in the engine. They communicate via the module API, and the engine also provides other infrastructure, native and JavaScript, for A/B testing, BI logging, and more. Each extension is being developed independently as well. So most of them are open source projects. You might know a few of them: React Native Navigation, Camera Kit, our keyboard extensions, notifications, UILib, Interactable, Detox, and more. React Native Navigation, for instance, is being treated as a completely independent product. So here you can see React Native Navigation's end-to-end test suite using Detox for both iOS and Android. That's the V2 of React Native Navigation, which will be released very soon, we hope.
In order for developers to be able to test their module changes on the full app without seeing any work in progress on other modules, we are running a special integration flow. So let's take a typical work week. Module development is being done on its own example project, where it's running on top of the engine. When developer finish the development work, they create an internal, that's not passing. An internal release candidate for that. And this release candidate process creates a special dog food flavor for our full app. That's the orange icon that you can see there, where it integrates all the stable version of each module and the release candidate version of that module. This allows developers to test their changes on a stable environment before. And you can see they are marking the module as safe for production, aka GA. So when it comes time for the weekly release, the production version, as you can see the blue icon on the bottom, it picks up all the modules in the GA and releases it to the EPA to TestFlight and the APK to Google Play. Okay, so you can see the Wix app repo is essentially, it's only a package JSON with the dependencies and a few engine configuration and some build scripts. That's it. By default, for standard builds, it will just use the version marked as GA, saying they're ready for release. This is an example from the Wix app. Here we can see the dependencies with all the modules that are configured to use GA. In fact, triggering those special flavor builds, setting tags, and keep it all organized required building a special system for that. We call it Poco. Poco started as a little POC, so Poco and some Spanish little bit, Poco. Poco is a tailor-made solution. We use it for our module lifecycle. If it's for building a module or NPM tag management. Poco integrates with endpoints like the private NPM we use, the TeamCity, which we use for building the modules, GitHub for saving the code, showing the commits, and Slack for audit logs and events. Here we can see the module state in every point in time. As you can see here, the module version, the first column. Then you have the one-app build. This is this specific version on the one-app build, if success or fail, and also the NPM tags. Also show all the modules contained in the same released app. It enables creations of custom apps with the specific module versions, and also enables custom flows with different NPM tags per build. For example, when we need to upgrade the React Native version, we can create custom tag for the version that we built. So let's talk about our infrastructure stack. What are we building? We're building iOS, Android, JavaScript. Our infrastructure, the hardware, is Mac OS agents over VMware with nested virtualization for running the x86 Android emulators and also the iOS emulators, of course. The CI server, as I showed you, is TeamCity. We use it for building, testing, and versioning. And then the modules are being published to internal NPM, which plays nicely with React Native. So how does the dev cycle look like? Module or engine code change are pushed to GitHub. This code change is triggering module build on TeamCity. Continue to test step, and if all good, get version and publish to NPM. The internal release process, which is the RC process for a module, is being in Poco. It's triggered in Poco. As you can see, this triggering the one-up, the Wix app application build with this specific RC version of this module. And if all okay, the IPA and the APK are uploading to Upblade. The Wix app release, the GA thing that we released to the stores, is also triggered via Poco. And this is building in TeamCity, which the GA thing that, like I showed you before, the package JSON with all the GAs. And then the IPA is uploading to TestFlight, and the APK is going to Google Play. We use versioning scheme that supports patching. Why? Because life sucks, and sometimes you have bugs, and you need to create some hotfixes. We do that by creating a branch from previous release of a certain module, by following the state of the project's Git tree. Version is automatically calculated in the following manner. Major is from the package JSON. We take the major in the version package JSON. The minor is the number commits in the master. And patch is the number commits in a certain branch since diverged from the master. So if the build is master, it will be 0. When building the app, we keep a shrink wrap file containing all the resolved module versions. When we need to release a hotfix, we use that shrink wrap state and only change patch versions of the patched modules.
So testing is a big part of our workflow. So here's a testing pyramid, of course. We use Jest for testing our unit logic. Most of the components are written with Remix, which is our opinionated way of using Mobix, which is also open source. Surprisingly, we use Detox for end-to-end tests. So in the past 11 months, we've been using Detox to automate and improve our release process. We've used it in multiple testing scenarios, crunching tons of synchronization bugs in Detox itself, and came with a few understandings as to what makes sense to testing with Detox. So in general, there are two types of tests that we do using Detox, production E2E and mock E2E, which is like UI automation. So the main characteristic of production E2E is that it involves every part of the system. So it is the closest thing to the real user. It has many uncontrollable variables that each can affect the test outcome. If the network is down,
the test will fail.
if our server has issues,
the test will fail.
And if it gets a different A/B test variant for each run,
the test will fail.
Yeah, probably.
For sure.
Yeah. So the pros of production E2E are that these tests are as close as possible to a real user experience, logging with the real users against production endpoints. They're very easy to set up, and they're very easy to write. Just find an element, interact, and expect, and for something to happen, and that's it. These tests can provide very high confidence if they were not flaky and slow. So the main benefit of these, that they can help QA engineers replace manual testing methods, but again, it will be never rock solid. Therefore, it is very hard to maintain. Mock E2E, on the other hand, tries to eliminate all those settings, and by just adding controlled and predictable environments, replacing all endpoints with a mock server and data. Server and client communication can be tested using contract tests, which is something that we try to incorporate as well. So the pros of mock E2E, that these tests are much closer to the actual code. They're stable, using mocked endpoints, controlled and predictable environments, such that provides the same input all the time on every test. They're very easy to maintain. Once they've been written, they just work. The cons are that they require more setup and much harder to write, since we need to take care of mocking and controlling our mock data rather than just the server or local configuration. So how do we mock with Detox? So in order to use mock server, we need to make sure the app knows it should not try to connect our real server endpoint. Our way of doing it is by creating a new flavor of our JS bundle, one which uses different endpoints than the production one. So this is supported by Metro Bundler already, and by creating any file.e2e.js, we can override any file.js and create a custom JS bundle. So we're setting mock endpoint in endpoint e2e.js. This will replace the one in endpoint.js. And then we're adding a certain configuration to rncli config to the root setting, get source extensions. This will prioritize any given source extensions over the default ones by triggering each of these commands on the bottom of the screen. The bundler will take the e2e.js over .js. So instead of bundling endpoint.js, we just bundle endpoint.e2e.js. This is an actual test from our mock E2E test suite on the engine itself. Mock server is an object that lives inside a test runner node process. It can be altered during the test and using simple function calls. And once we set the mock data, we just launch the app. Now we can run mock tests and verify that the application can persist login information and it does not show login window in subsequent launches once the user has logged in.
You know, they say if it's not monitored, it's not working. So what are we using for monitoring for our app, for our one app? We use Sentry, which is a cross-platform crash reporting and aggregation platform. We are using this to track JavaScript errors. For performance, we are using Graphite to store app metrics. For example, response time or how much time it took to render a screen. Grafana is UI, is for dashboards on top of Graphite. Anodot help us to detect anomalies. This is server side. Also for server side, we use New Relic. This is also for dashboarding and metrics, and as I said, server side. For business, we have an internal tool that developed by our BI team, and we use it, for example, to monitor user flows and stuff. So cross-app upgrades are hard, really hard, and we still have no good way of making it easier. So these are mainly upgrades that include breaking changes in React Native or Xcode, Gradle, or other independent libraries like our imminent upgrade to React Native Navigation v2 with breaking API changes. Obviously, upgrades are cross-group effort. So we start by upgrade open source libraries to support new breaking changes in React Native, either introduce breaking changes in the library or not, but follow Semver. Each is being tested with its example or test project. These projects are the engine dependencies, so we upgrade our React Native and those dependencies on a branch, and we publish the engine to internal NPM with a custom tag using Poco. Test engine against all of the updated libraries. This engine, also the engine is a TDD project and has 100% unit test coverage. It also has an extensive mock T2E test suite written in, surprisingly, Detox. Once all of the above is done, we start testing our internal models with the new engine versions, fixing it and updating. But still far from perfect. Some breaking changes are unfixable. So many times we rely on a native implementation in our open source libraries and internally. Classes accessibility and implementation change all the time. So we are thinking about defining and proposing a native API to access and extend React Native. In the meantime, we maintain a fork of React Native, make changes, build and publish to our private NPM repo. So all internal projects get this custom version, and we often propose them as pull requests to React Native.
So a bit about our future plans. As we said, things are not perfect for us, and we strive to automate as much of the process as we can. So We call this process zero QA, or in the more practical name, approximately zero manual QA, because you cannot get zero. So we incorporate both mock T2E and production E2E in our development and release process. And at least that's where we're aiming. Not everything is fully tested as we would like it to be. Setting our goal at continuous deployment, we're working hard to lower our reliance on manual QA. So this is our approximately zero manual QA plans to be implemented in the short term. So developers write their unit tests, mock T2E, and contract tests as part of the product development. This is incorporated in CI. Every build and every commit runs all these test suites, and this should not take more than 5 to 20 minutes. This will generate a short feedback loop to the developer. QA engineers use Detox to automate their regression and progression suites. These tests will never be rock solid, and hence they will be decoupled from the development process in a different build with a different lifecycle. They can eliminate most of the manual work, and when a test is broken, it can be tested manually. It will not stop the continuous integration process. Scenarios, of course, are owned by the QA team. Collaboration of developers and QA. So Dev and QA are obligated to synchronize. QA will need to educate the dev team on how to write high-quality scenarios and review mock T2E suites. And by having a good grasp of what we've already have covered in mocked E2E tests, QA can reduce the amount of production E2E to the bare minimum. Zero manual QA will add greater level of confidence, but the actual deployment process is still not entirely figured out. So true continuous for multiple independent modules is not a trivial task. We would need a way to unbundle each module and being able to shrink wrap it separately in a production bundle and send only its changes via like a code push style system. And then integrate everything on the device itself, while keeping the JS bundle load time as low as possible. We're working on what we call Purple. It's another flavor of the app, in addition to the production blue and the dog food orange. This is our Expo-style engine. We want to be able to send a bundle anywhere, as long as the bundle is supported by the installed engine on the device, on that Purple version. It will be able to run, making it essentially like a browser for our React Native JavaScript code. So that's the state of the current things, and it might change tomorrow. We don't really know. That was it. Thank you very much.
Thank you all.